Hello, in this video we're going to determine whether a total cost function is concave at a certain point or convex at a certain point. And also we're going to try to find the inflection point on the total cost curve. Here's our cost function where Q is the quantity of output. Is the cost function concave at Q equals 2? If the second derivative of the cost function is negative at Q equals 2, the cost function is concave at that point. And what does that mean? It means the tangent line on the cost curve at Q equals 2 will lie completely above the graph of the function, above the cost function, at or near Q equals 2. So we need to get the second derivative, so the first thing we do is get the first derivative, which happens to be marginal cost. So taking the derivative of this equation, the derivative of 10 here, that's just going to drop out at 0. Derivative of 60q is 60. The derivative of minus 18q squared, bring the 2 down in front. So 2 times 18 is where the 36 is coming from. And then we're going to subtract 1 from the exponent here. So we're just left with q. And then likewise, the derivative of this final term is just going to be 6q squared. Taking the derivative of the derivative, or the second derivative, we get minus 36 plus 12q. We're going to evaluate that second derivative at q equals 2. And as you can see here, the second derivative is negative. Minus 36 plus 24 equals minus 12. So where q equals 2, the graph of the cost function is concave. We'll look at the actual graph in a minute here. Moving on, taking the same cost function, but this time looking at whether the graph of the cost function is convex at q equals 5, a different point. Here, if the second derivative of the cost function is positive at q equals 5, the cost function is convex at that point. What does that mean? A tangent line on the cost curve at q equals 5 will lie completely below the graph of the cost function at or near q equals 5. We once again get the first derivative. As we just shown, the second derivative equals this. Plugging 5 into the second derivative for q, we see the second derivative is positive. Minus 36 plus 60, or 24. So in this case, the cost function cost curve is convex at q equals 5. The second derivative is positive. We want to find the inflection point on this cost function. So this is going to be where the graph changes from concave to convex, or vice versa. The second derivative will be 0 or undefined at the inflection point. First derivative, second derivative, set the second derivative equal to 0. Solve for q. Q equals 3, so at q equals 3, we are at an inflection point. Here is that cost function. The inflection point that we just found here is where q equals 3. Anything to the left of this point, the graph here of the cost function is concave. Notice that if we have a tangent line at q equals 2, that tangent line lies completely above the graph, so it's concave. Over here to the right of q equals 3, we have the convex portion of the cost function. A tangent line at q equals 5. Notice the tangent line lies below the cost function, which is again an indication of the graph being convex there. Okay, I hope you found this video helpful.